everybody. Welcome to Mrs. Baker's Monster Paper for Module 10. This is question 5. So the positions of some common metals in the reactivity series are shown. So the most reactive is magnesium, going down to the least reactive being copper, and aluminium in the middle. When magnesium is placed in aqueous copper 2 sulfate, a displacement reaction occurs immediately. Write an ionic equation for the reaction. It says here to include state symbols. So we know that we started with aqueous copper sulfate, and it's told us that magnesium, which we know is a solid at room temperature, is more reactive, so it's going to displace the copper from the copper sulfate. The sulfate isn't actually going to change oxidation state. It is a spectator ion in this case. So magnesium as a solid is going to be added to the aqueous copper. Now remember, because sulfate is a compound ion, we don't include it in our ionic equation, and that is in an aqueous state at the moment. It has a 2+ charge on it. But first of all, we know it's got a 2+ charge because it says it's copper 2 sulfate. Then those are going to make magnesium as a 2+ ion, and that's going to be in its aqueous state. And we are also going to make copper in its solid state. And copper doesn't have any charge anymore because it's now just copper metal, and all elements have an oxidation state of 0. So state 2 observations that you would make when magnesium is placed in aqueous copper 2 sulfate. There are 3 observations actually that you would make. The first one is that the solid magnesium would disappear. So solid magnesium would dissolve. You would probably get the mark for saying disappears, but a better scientific term is dissolve. And then a pink brown solid would appear because, of course, you are making copper metal, and copper metal is always described as a pink brown solid. The other thing that you could have said as an observation would have been that copper, we know, makes that lovely blue colored compound. So copper sulfate is blue. As we stopped making copper sulfate, as we turned the copper sulfate into copper metal and magnesium sulfate, well, that color would disappear or start to get paler until eventually, once you'd made fully completed your reaction, magnesium sulfate is actually a colorless solution. So you could have written words to the effect of a colorless solution forms, or the blue color from the copper sulfate gets paler over time. Either one of those would have also got you a mark. When aluminium foil is added to aqueous copper sulfate, no immediate reaction takes place. Well, we know because it's told us in the question above that aluminium is more reactive than the copper in the aqueous copper sulfate. So technically, it should start that displacement reaction in the same way. But we know that aluminium forms a stable oxide layer, and that makes it appear less reactive than it actually is. So when we say explain why, we can say a stable coating of aluminium oxide makes aluminium appear less reactive than it actually is. Aluminium powder reacts with iron 3 oxide to produce aluminium oxide and iron. Write a chemical equation for this reaction. Well, we know that chemical equation means symbols. So we've got, first of all, aluminium as a metal reacting with Fe2O3. Well, we know that it's Fe2O3 because each ion has a 3+ charge. So we've got 2 of them, 3+, which makes 6+ overall. And we've got oxide, we know it's a 2-, it always is. So it's 2-, 2-, to get 6-. We have to balance them out. Okay, and the lowest common multiple of both 3 and 2 is 6. Therefore, that is going to make, when we add them together, aluminium oxide and iron metal by itself. Same way that we know that aluminium is Al2O3 is because aluminium is in group 3, so it also forms a 3+ ion. So it's going to be the same ratio of atoms in aluminium oxide as it is in iron oxide. Now we just need to balance it. Never forget to balance your chemical equations. Well, we've got 2 aluminiums over here, so we need 2 over here. And we've got 2 ions here, so forth. We need 2 ions over here. And then we're balanced.